Alrighty, we're back for L'Hopital's rule. You're all excited about L'Hopital. No? Nobody? Yes, you are. Who did the bell work? Emilio, walk me through it, buddy. Particle moves along the x-axis with a speed of v of t equals t minus 3 squared, cos 2t.
We need to find the zeros.
Could be. All right, so what are we going to do? Why do you need the derivative?
I know because we only the zeros.
There you go. It's already v of t.
Yes.
So 0 equals t minus 3 squared cos 2t. Well, this one's real easy. It's going to happen when t equals 3. This one is a little trickier. So where is cosine normally 0?
At pi over 2 or at 3 pi over 2.
Exactly. So this is like pi over 2 or 3 pi over 2, but that's not the answer because it's 2t. So it's going to be like 2t equals pi over 2 and 3 pi over 2 equals 2t, which means t is actually going to be pi over 4 and 3 pi over 4. Right?
Yeah.
Because we got to solve it. For 2's, don't look scared. All right, so now, what do we got to do? Well, we're going to look at our endpoints. We obviously can't go beyond those. So 0, we'll put 0 and 5 in there. Then we got to put in all our zeros, right? So like pi over 4, 3 pi over 4, which is 9, roughly 9 over 4, which is less than 3. So it'll be 3 pi over 4, and then it'll be 3. Whoa. You know what? Those are a little too close together. Ay, pobrecita. Está bien.
That's a big Mr. Radford.
So we'll do pi over 6, and then we'll do pi over 2, and then we'll do 5 pi over 6.
You pick the worst numbers.
And then we'll do pi. Guys, why would I pick numbers that are pi over something? Let's use our big brains.
It's greater than 0.
No. Well, sure, but
It's in
no.
between both things.
Okay, sure, but no. Because what? No, say it. I think you were onto something.
Because the zeros are with pi.
Okay, so part of it is because the zeros are with pi. That's what you're on.
It's easier.
Because why?
Because you're using
Because we're using cosine.
Ah.
Right? If I put it like, who wants to do cosine of like 6? That sucks. Right? But cosine of like pi over 6? Hey. So anyway, yeah, shut your mouth. Just kidding. All right, so here's the fun thing about this one. Anything squared is going to be what? Perfect. So it's going to be a positive times, and all we got to do is figure out what is cosine of 2 pi over 6. Well, that's the same as cosine of pi over 3. Which quadrant am I in?
Pi over 3.
1 first, and that would mean the cosine is positive. So the whole thing's positive. Yay. All right, then we'll do pi over 2, which is really cosine of pi, because 2 pi over 2 is just pi. Oh, cosine of pi is negative. It's negative 1. So it's negative. It changed. Yay. All right, let's do 5 pi over 6. First one's always squared, positive. Cosine of 5 pi over 3. We're in quadrant 3. No, 5 pi over 3 is in fourth quadrant. I was like, wait a minute, that's not in the third. It's in the fourth, so it's positive. Isn't 5 pi over 3 in the fourth quadrant? Isn't cosine positive in the fourth quadrant? Why are y'all trying to gaslight me? So it changed again.
Couldn't we just have done that by looking at the unit circle?
That's what we're doing, the unit circle. This is why y'all have to know the unit circle. All right, and then cosine of 2 pi.
I have a question. In your brain, you don't have to do that. You just look at the unit circle and you know.
Yep.
0.
So there's no change here. So when did it change directions? At time equals pi over 4 and 3 pi over 4.
Change. I change.
Yep. Good. All right. Look at us go.
Break.
We're not having a break. Woo, sorry. You chill. ¿Qué? Nada. Part-time Paulina, do your work. Otherwise, we're going to start calling you by your new nickname. No Time Paulina. We need part-time Paulina back. She does more work. All right. It's okay, part-time Paulina. You're still doing better than back table. I mean, they're the only ones that failed the last assignment.
You already graded them.
Ah, those ones. Your class, yes.
Did I
And they
get-
failed. Well, we know they failed because none of them were here.
Wait, but I have a question. Is it a 70 forever?
No, I don't know. Probably not.
Yes.
No. All right, let's listen up. Emilio, Miguel, boys, flirt on your own time. At the onset of our study of derivatives, we used a limit to find the derivative. If you remember, and it's on the wall, we did that. Amazing. In the same sense, L'Hopital's rule uses derivatives to find limits of certain functions. In particular, limits of indeterminate form. So remember, before we got these ugly things that were like 0 over 0, infinity over infinity. And what did we have to do? We had to do some factoring and go back to pre-calc. And that was lame. Well, not lame, but it was long. So what we're going to do is we're going to do an example of that. And then I'm going to show you a better way. Don't cry, Matthias. It's okay, buddy. So if we look at that, try to evaluate this one by subbing in 3. All right. Well, when I do that, I'm going to get, let's see, 9, 18, minus 3 is 15, minus 15 is 0. Then I'm going to get 9 minus 3 is 6, minus 6 is 0. Oh, that's sad. I got 0 over 0. Algebraically factor, and let's cancel out some stuff. Limit, x approaching 3. Let's see, this is going to be multiplied and negative 30, add to 5, negative 1, so we're going to get negative 6. So it's going to be 2x plus 5 and x minus 3. Over, multiplied and negative 6, add to negative 1, we're going to get x plus 2, x minus 3. And lo and behold, if you didn't know how to do that one, go back to pre-calc. Come see me later. All right, then we get 2 times 3 is 6 plus 5 is 11. 3 plus 2 is 5. Ooh, we found a limit. Because that's a removable point of discontinuity. No. There's one planned later.
We should switch now.
Nope. All right. So now no, you put that in. L'Hopital's rule makes finding a limit of this form even easier. So let's write out L'Hopital's rule. When we have the limit as x approaches a of f of x over g of x is indeterminate. Part-time Paulina is indeterminate where a is a real number, infinity or negative infinity.
As x approaches a.
Yeah. Then we can use the limit as x approaches a of f of x over g of x is really the limit as x approaches a of f prime of x over g prime of x. L'Hopital. Only if it's indeterminate. It has to be like 0 over 0, infinity over infinity, negative infinity over infinity, negative infinity over negative infinity, infinity over negative infinity. Indeterminate. There's other ones too, but you don't learn about those yet.
I know that makes sense.
I know, right? So we can take the derivative. So, shall we do it?
Wait.
Wow. Did you all hear that online? Did you all hear them yell at me to wait? Psh. Harsh.
That's what we think when you write so fast.
Did I write that fast?
Yes, I didn't understand until I saw the formula.
Okay. So now, if we... You can't see when I'm angry. Not really. All right, Pedro's done, so let's move on.
Not done, mister.
Okay. Yakaman!
I understand.
So, this is the same function. Can we take the derivative? Can we use L'Hopital?
Yes.
All right, so this is how we're going to do it. We're going to write a limit as x approaches 3. We're going to write L'Hopital, LH. What is the derivative of the top?
4x minus 1.
What is the derivative of the bottom?
2x minus 1.
Then we plug in 3. 12 minus 1, 11. 6 minus 1, 5. Samesies.
That is very easy.
That easy. It's
Told you you're going to like it. L'Hopital.
I'm gonna write 6, so you have to.
Aren't you all excited about L'Hopital? He makes everything easier.
Why didn't you teach it this way from the start of the way?
Let's think about this for a second.
No.
The beginning of the year, you knew what a limit was. Did you know what a derivative was?
But you could teach it.
Did you know how to take the derivative?
I did.
Okay, you did, but they didn't. The point is, you didn't know how to do the derivative yet, so I couldn't teach it.
That's how
This is a serious question.
the answers quick.
Could you?
Who?
Peter.
I don't know.
Peter.
Could be.
Like, is it insider? Like, more
I've tried it both ways, and I found usually starting with limits is better. I don't know. Just is. Gets you to start thinking about things differently.
I know. We're gonna start sweating closer.
All right, here's two other ones. I'm Matias. All right. Pertus, keep them in line. All right, two other limits that we learned earlier were also indeterminate form. We investigated them and we found that sine x over x was 1 and 1 minus cos x over x was 0. Let's use L'Hopital. The limit as x approaches 0. L'Hopital. The derivative of sine x is cos x. The derivative of cos, or the derivative of x is 1.
I have a question. What did you write? You said leave and then something else is gone.
L'Hopital. LH.
We have to put LH.
If you use L'Hopital's, you must write LH. Because you need to denote that you did L'Hopital's rule.
Because Hospital has to name everything.
the same answer.
But you would have shown factoring. You're not showing factoring, so you got to show L'Hopital.
It's just a different way of doing it.
Exactly. So you got to show that you did that a different way.
So,
And cosine of 0 is 1. Je limit as x approaches 0 of, ooh, got to write L'Hopital.
You always have to write
I literally just said yes.
What if I forget missing?
You will get the answer wrong,
Why?
because I'll take away marks for you not writing it properly in notation.
That's
So, negative cos of x, the derivative is negative sine of x. So, negative sine of x is sine of x. Derivative of x is 1. And sine of x is 0. It's almost like we know what we're doing. I know, right? Don't you feel smart right now? Yeah, you do.
I felt good until we
You
got
feel
to the
smart.
side coast part.
You know what? That is not my fault that you don't like her. Blame whoever taught you pre-calc or something. Don't say their name out loud. We're on camera. All right. Use L'Hopital's rule to find the values for each of the following limits.
Hello.
Wait.
All right, ready? All right. So, if I plug in cosine of pi over 2, 0. If I plug it in here, 0. Do not write equals. If I write equals 0 over 0, that's wrong. Because it doesn't equal 0. It equals indeterminate.
So if you write equals,
I haven't done that yet. I plugged it in. Now I can do the limit as x approaches pi over 2, L'Hopital. And I will get sine of x over 1. And sine of pi over 2 is 1. Yay. Amazing. Plug in 0 up here. I'm going to get 0 minus 0. Sure you do. 0 plus 0. What's up? Because otherwise it's wrong. Because you took the derivative. You applied L'Hopital's rule. You have to show that you did it. All right, so here I'm going to get 7 minus cos of x. Because you guys got me talking about it and I got distracted. But you're right. All right, 2x plus 3 cos of 3x, chain rule. All right, and that is equal to 7 cosine of 0 is 1. That's 0. Cosine of 0 is 1 times 3, so it's going to be plus 3. And we're going to get 6 over 3, which is 2. Look at us go. Hope so. All right, sine of 0 is 0. This is going to be 0 plus 0. So we're going to have to L'Hopital that stuff. X approaching 0 of L'Hopital. Hey, that's a product rule. So this is going to be cos squared. And then the derivative of cosine is negative sine, so even though it's technically plus, it'll be negative. You know what? If I do it a few more times, maybe you'll start to remember too. No, because this is minus this. Because it was plus negative sign. Yeah. No, it's all good. Plus 1 plus 2 cos 2x. And we plugged in 0. Cosine of 0 is 1. 1 squared is 1. Sine of 0 is 0. 0 squared is 0. Over 1. Cosine of 0 is 1 times 2 is 2. So 1 plus 2. And we get 1/3. Amazing. Are you ready for a big one? Woo! Here we go. It's not that bad. Don't worry about it. All right. What does that note say there, Matthias? L'Hopital. All right, let's look at it. So first of all, I plug it in. Cosine of 0 is 1. Cosine of 0 is 1. 2 minus 2 is 0. 1 minus cosine of 0 is 1. 1 minus 1 is 0. All right, so let's do some L'Hopital. Je limit as x approaches 0 using L'Hopital. 2 cos x is going to be negative 2 sine x. Your funeral. Minus 2 times the cosine. Derivative of cosine is negative sine, so I'm going to put a positive. So plus 4 sine 2x. Right? Why is it 4? Because I had to multiply by the chain rule part, right? Alrighty. And then derivative of cosine is negative sine, so minus negative is going to be plus, so 1 plus sine x. Amazing. All right, let's try it out. Ready? Oh, let's not put equal. Sine of 0, 0. Plus 0. So it's just 0. Sine is... Oh, wait a minute. I didn't take the derivative, right? The derivative of 1 is nothing. I was like, wait, we're going to get 0 over 1. That's not good. We're supposed to have to do it twice. It's because the derivative of 1 is nothing. My bad. So it's just 0 over 0. Did you catch that? Don't worry about it. So we're going to have to do L'Hopital again. L'Hopital. Well, because it's still indeterminate. 0 over 0.
So you have to just take the derivative until you finally get it.
Heck yeah. Derivative of sine is cos, so negative.
If you and you have no more things to do.
I'll let you know next year when you're in BC. You don't have to do it this year. All right. And then the derivative side is cos. Let's plug in some 0. Cosine of 0 is 1, therefore it's -2. Cosine of 0 is 1, therefore it's 8. Cosine of 0 is 1. We get 6. Amazing. I know, right? So good, you're ready to keep going.
No, wait, not wait. No.
Looking at you. Yo creo que de la única persona que el Torano
Matthias. All right. How about if we do it at infinity? What about at infinity? Okay, let's do it. So, what would we do? Before, when you were in pre-calc, you had to divide everything by the greatest degree in the denominator. Hitting your head with a water bottle will not help you. It will likely make things worse. Oh, you don't have to apologize. You should probably apologize to yourself. I mean, you're hitting yourself in the head with a steel water bottle. I know it's hard, Pertuse. I know it's Friday, last block, but make better choices. Otherwise, I'll have to tell Suzanne. I mean, I can't believe Matthias is letting you do that. But he loved you.
No, bad boy. Wait.
Very bad boyfriend.
What did you do?
Matthias, let
No.
Pertuse hit. Okay, so let's do this now. Ready? So now, when we do this, right, if we plug it in, we're going to get 4, right? Minus 5 over infinity is 0. 1 over infinity is 0. Minus 3, so we get -4/3. That's how we did it in pre-calc. All right, but
We didn't do that in
whatever. Yeah. When it's 1 divided by infinity, it's 0. Pertuse. No, Pertuse has nothing. Okay. Alrighty, so if x approaches, I'm going to leave a space for infinity, and y gets close to a number, it converges on a number, fancy math speak, then there exists a horizontal asymptote. Right? All right, so then if we were to like validate our answer, remember, what did we really do? What was the rule in pre-calc? Top heavy, bottom heavy, power equal. What is this one? Is this one top heavy, bottom heavy, or power equal? Well, whatever, so I typoed. It's okay, I know y'all angry. It's Friday, I'm making you do work, I get it. Pertuse, is this top heavy, bottom heavy, or power equal? Seriously, girl, stop hitting yourself. It's power equal. You should listen to your boyfriend. All right. So it's power equal. So what did we do? We simply divided the leading coefficients, right? So this would be -4 over the, well, okay, 4 over -3. Same thing. Fine, it's 4 over -3, which is exactly the same as -4 over 3. Yeah, there's a break after this page. Well, I'll try to move it next time. Okay, part-time Paulino. More work, less break talk.
We should do it. I worked a lot.
Wait.
No, we're going to use L'Hopital's rule. Ready?
Scroll up.
No, we're using L'Hopital's rule. All right, Pertuse. If I plug in infinity, what does the top go to? It's infinity squared minus infinity, so infinity. And then on the bottom, it would go to,
Negative.
yeah, dude. Look at her know stuff. All right, so we're going to do some limit as x approaches infinity. See what happens when you stop hitting yourself in the head?
Yes.
Pertuse knows stuff. What's your question, Matthias? No, dude, that's not how that works. You got to do exponents before you do the multiplication times -3. So it's infinity times infinity, which is infinity squared, times -3, which is -3 infinity squared, which is still just negative infinity. All right, so we're going to do some L'Hopital. Well, do L'Hopital. So 8x minus 5 over -6x. And when I do that, I'm going to get infinity over infinity. So we L'Hopital again. Limit as x approaches infinity of L'Hopital is 8 over -6, which is -4/3. What? Same thing.
We've only finished one video. Like, we're in the
Yeah,
second-
we're doing good, man. We're doing good time.
We're in the first video.
No, this is the second video. And we're going to get through this page. Are you ready? Here it comes. All right, L'Hopital's rule. We're going to find this one.
I didn't understand.
What didn't you understand?
I don't understand why you said figure.
L'Hopital again?
Yeah.
Because we got infinity over infinity when we tried to sub it in.
But and wouldn't it be like you have to get rid of all the x?
Oh, sorry, it's infinity over negative infinity, but
But you want to get rid of all the x.
not necessarily. But in this case, yeah, we needed to.
But so then what?
Well, look, do the next. Watch the next one, and you'll see. Because the next one we don't get rid of all of them. So that's why I'm saying, like, watch the next one. Because now when I plug in infinity, I'm going to get infinity over infinity. So I'm going to have to use L'Hopital. So the limit as x approaches infinity of 10x minus 1 over 9x squared minus 4x minus 3, which gives me infinity over infinity. So I'm going to do it again. I forgot L'Hopital. Guys, you're talking a lot. I know it's Friday. Come on. 10 over 18 minus, 18x, sorry. Minus 4. This is going to give me 10 over infinity, which is effectively just 0. So, using your knowledge of horizontal asymptotes of rational functions from pre-calculus, explain why the result is what it is. All right, so what does this mean? There exists, yes, a horizontal asymptote at y equals 0 because bottom heavy and so to the extreme right in other words, x approaches infinity. We approach the horizontal asymptote. Really, the most important part is like this. Wow, that's bad. Right? It's the fact that it's bottom heavy. Like in your pre-calc, you would have been like, oh, it's bottom heavy, so it's 0. Because you learned in your pre-calc that all of your rational expressions had that rule, right? Like top heavy, bottom heavy, power equal. 0. Always on 0. And L'Hopital's just proved it. Go L'Hopital. Alrighty, we're gonna finish it up. So, we had our break. It was amazing. Emilio, shut your trap. Alright, so use L'Hopital's rule to find each of the following limits. So, if we plug in infinity, the ln, the natural logarithm of infinity is infinity. And the root of infinity is infinity. So therefore, we must do the limit as x approaches infinity using L'Hopital. And, this is where it gets interesting, the derivative of ln is the derivative of what's inside over the original, all over 2 times.
Okay.
Thank you. 1/2. And then usually what we do is we just put it on the bottom, right? We do our shortcut of like, well, if it's x to the power of 1/2, it's going to be x to the power of negative 1/2. And look at all them 2's cancel. Bam. Bam. I have to move my face. My face is in the way. Alrighty. And so that just gives me,
X
X over square root of X.
well, technically it gives me 1 over x over 1 over square root x. And then I would keep, change, flip,
So would it just be X?
which
times
would be the square root of x over x, which is also really just 1 over root x. I don't care which one. Either of those work. Oh, both are right. Alrighty. And remember, we're taking the limit of this thing. So the limit as x approaches infinity, of 1 over square root of x equals
You don't have to put L'Hopital.
1 over infinity, which is 0.
We have to put L'Hopital.
I technically already did, but yeah, we could put it again over here. Amazing. All right, next one. Do some product rule.
Wait.
No.
No,
Oh my goodness.
Wait,
Hey, Pertuz, you know what works really well? When you like put the pencil in your hand and you like write while we do the lesson.
Yes.
Yeah, just saying. I mean, what would Susanna think? What would Susanna think? Yeah. The other one, probably not. All right, so if we do this one and we put in a half, we're going to get cosine of pi over 2, which is 0. Here we're going to get e to the 1/2 minus e to the 1/2, so that's also 0. All right, so we got to L'Hopital this sucker. Limit as x approaches 1/2. We're going to L'Hopital. And the top is going to be a product rule. So it's going to be the derivative of x, which is 1, times cosine of pi x, plus x times the derivative of cos pi x, which is actually negative sine. So we're going to switch that to a negative. And then we're going to do sine pi x. But it's also a chain rule. So then multiplied by pi. And then we're going to put the whole thing over. E to the power of x is e to the power of x. This is a number. It goes away. Now we just plug in things. All right, 1/2. Cosine of pi over 2, that's 0. Minus 1/2 times the sine of pi over 2, which is 1. Times pi. Over e to the 1/2. Which is negative pi over 2 square root e. So all I'm doing right on the top here, I would get negative pi over 2 divided by e to the 1/2. Keep, change, flip. Basically, we just end up with this. If I did it too fast, I'm sorry. All right, shall we do another one? And now, we do it at 0. E to the power of 0 is 1. 1 minus 1 is 0. E to the power of 0 is 1. 2 minus 1 is 1. Ln of 1 is 0. L'Hopital. The limit as x approaches 0 of 1 is 0. E to the x is negative e to the x. It doesn't even change. I am sorry. Thank you. I am glad that despite the fact that Pertuz can write nothing on her page, she knows that I need to write L'Hopital. Oh, look at you go.
Look at the camera.
Okay, I looked at the camera for you. The derivative of the inside is negative e to the x. And then for natural logarithms, we put it over the original statement. Well, that's a little ugly. So it would be the limit as x approaches 0, using our L'Hopital. And we're going to keep the first one. And then we're going to change it to multiplication and then flip the second one. So 2 minus e to the x over negative e to the x. Obviously, these cancel. Hallelujah. And then we plug in 0. E to the 0 is still 1, so we get 2 minus e to the 0, which is 2 minus 1, which is 1. Look at us go. We're cooking. We're cooking.
I think I'm getting cooked.
Okay, I'm cooking, you're cooked. Sucks to be you. Yes, Matthias. Oh, sorry. Part-time Paulina's not done.
Mister, you woke up today very suspect.
It's true. I did. Happens when I'm sleep deprived. I only slept like 4 hours.
Why?
I don't know. I couldn't sleep.
You know what?
I was like wired last night.
Also, woke up super early because there was like upstairs of the house.
Mister,
I got scared and everything. There was
I believe you.
thunder, and then I woke up at 4
All right. I'm going to pause you. We're going to finish story time after the last question.
Chontadura juice is really good for that.
All right, we're going to keep going. Ready? If I plug in 0, I get 0 times doesn't matter. 0 times anything is 0. And then here I'm going to get 1 times sine of 0, which is 0. Gotta L'Hopital that sucker. The limit as x approaches 0. This is a product rule. So, Matthias, tell us how to take the product rule of x cos x.
X, negative sign. X. Over. No, sorry, wait.
All right, I mean, that's kind of an awkward way to do it, in my opinion, but sure. It's right, buddy. It's okay. Chill out. All right, on the bottom, the derivative of this is another product rule. So I guess we'll do it the same way, where you guys want to take the derivative of the second one, because I don't know. That's what you want to do, so we'll do that. All right, derivative of sine is cosine. The derivative of x plus 1 is 1 times sine. Amazing. Forgot my L'Hopital. And Pertuse forgot to tell me.
You would have gotten everything wrong.
Only thing that she's been telling me all class, and she can't remember to tell me this time.
You know that you would have gotten the entire thing wrong.
It's true.
Yes.
All right, so 0 times, doesn't matter what sine is, 0 times anything is going to be 0. Cosine of 0 is going to be 1. 0 plus 1 is 1, times cosine of 0 is 1. Plus sine of 0 is 0. So I get 1 over 1, or 1. Amazing.
We're done.
And now you do the practice.
Go up.